Welcome everyone to the CompTIA Sec Plus 601. In this video, we will go over 1.1 to 1.4, which is the attacks, threats, vulnerabilities. There are also the architecture and design, 3 implementation, operations and incidents response, 5 governance, risk, and compliance. So, the most important ones are the first 3. Make sure you actually know them. And for the last 2, it is good to know them for that boost of score. Let us begin. 1.1 Compare and contrast different types of social engineering techniques. So make sure all of these are used for social engineering. The most important one you have to know is phishing. Phishing is when scammers send you an email link, usually email message, and it includes a malicious link. And when you click on it, it leads into a very malicious web page where they could try and gather your information. Smishing is exactly the same but using SMS messaging. Vishing is using a phone call instead. Spam. Spam is email spam, essentially, and it may or may not contain anything malicious at all, or it might contain a lot of malicious stuff, which is usually phishing attacks. Spam over instant messaging is essentially the same as spam but using instant messaging. Spear phishing. Spear phishing is very different than normal phishing. Phishing is just sending email to everyone, a malicious email. Whereas spear phishing actually sends the malicious email to a specific set of individuals. Mainly it is used for example, sending it to an HR department only or only the cybersecurity department. The other one you need to know is dumpster diving. Dumpster diving is trying to look for confidential data inside trash. Shoulder surfing is looking over someone else's shoulder in order to gain is it proprietary information and confidential information through someone else's screen. This is usually used for inside threats. Tailgating is following someone who already has their thing ID'd through a man trap. Eliciting information is when you try to get information out of an individual through social networking. Whaling is a very specific type of phishing, which it only targets very high executives. It is not spear phishing if it is targeting the CEO, the CFO, or some kind of thing that starts with C. Prepending is an attachment to a normal source code. When you attach some kind of malicious message inside that source code and someone opens it, it could lead to a lot of malicious causes. Identity fraud is, I don't have to explain that. Invoice scams is sending fake invoices to finance departments so they could pay for it. Credential harvesting is using trying to find public information or public emails that public company emails which could be used to extend phishing. Phishing scope. Reconnaissance is using there's 2 types of reconnaissance. Uh, Active reconnaissance and passive reconnaissance. Usually, social engineering uses reconnaissance that is passive, where they try to find public information about the company and try to see if it's vulnerable through using public information, such as trying to find a CEO's email or trying to find a CFO's email or the HR department's email. Hoax. Hoax is essentially anything that is fake. Impersonation is trying to pretend someone that you are not, such as pretending to be a Microsoft employee. Watering hole attack is when the malicious actor tries to look for a website that a lot of people in a specific company access. So, for example, if a lot of them specifically access this login portal and the malicious actor managed to get a hold of that portal or make it into something else, when people try to log in, it may download a script to a specific one. As long as there is one person that clicks on it, it could affect the whole company system. And if you're wondering why, it's because there's a lot of like, I don't know, some sort of malicious program that will run inside the background and it will start spreading all throughout the network. That is called a worm, by the way. Typo squatting. Typo squatting is when you type, so instead of typing Google like this, you may misspell something like this and may lead you to another website that looks exactly like Google. And you may try and log in through I don't know, through Google like that, and the attacker will have your credentials because of this. So it's basically when you misspell something and you manage to access like a malicious actor's website instead. Pretexting is trying to make up a fake scenario to make your own situation more believable. It's usually used by malicious actors to make people believe that they're the person that is the customer, even though they're not. They're pretending to be a customer. Influence campaigns mainly work with propaganda. Hybrid warfare is when you use fake information in real life to try and spread it, and also using social media. The principles of social engineering, it uses authority by making themselves seem like they know more than you. They could be an IT individual by throwing you off by using a lot of very special technology words that you do not understand. Intimidation is trying to make you feel guilty about something if you do not provide certain situations. You do not provide certain information. Consensus is when you look at some type of service that they say they are and you believe them because they says like a lot of good reviews, such as on a website that says that the reviews may say, "Oh, it's a really good website," and consensus is when everyone agrees with that, so you start believing in it too. Scarcity when there is not a lot. So when they say you have won a free iPhone, but there is only five, there's scarcity over there, which makes you want to click on that link. Familiarity is trying to pretend yourself to be like the a really high top Fortune 500 company. So people will be familiar with that and they'll just click that because they also trust on that. Urgency is a way to make you feel like you have to like click on buttons, such as saying, "Oh, click now," and you click on that. Moving on. 1.2. Given a scenario, analyze potential indicators to determine the type of attack. I'll be explaining. So, there are a few. The first one is malware, and there are different types of malware. Ransomware is when all your files are encrypted and the attacker wants you to pay money, just straight up USD. Trojans are when you accidentally install thinking that it is like a game, it is like you think it's an antivirus and it actually turns out to be something else. Like, the Trojan horse. Worms are kind of like virus, but they actually when it enters into a system, that malware will spread without user intervention. Potentially unwanted pups. When you download an application sometimes, and somehow your search engine got changed. That's exactly what it's saying. Potentially unwanted programs. That I just provided was a potentially unwanted program. Fileless virus. So when you open like a link or something, or when you try to click download or something, it doesn't download it. Instead, the virus will get loaded straight into your memory section instead of you physically downloading it. So it will not appear in your folders. Command and control. Command and control is mainly used for DDoS, which is distributed denial of service. It's basically a lot of people pinging the server, just like by using bots. So bots report back to and command and control controls all these bots. So if command and control wants to DDoS Google.com, they could send in a lot of bots that overrides like a lot of requests, making the server overheat. So it'll cause a denial of service. Crypto malware is exactly like ransomware, but it uses crypto instead. Logic bombs, it's at any certain time that's randomly. It could affect at any protocols at all. It will cause. It's basically a bomb that just happens out of nowhere because there's like a lot of different conditions that just somehow matches up, and it just causes like a whole system to break. That is what everyone was kind of afraid of during the Y2K. Spyware. Spyware is when you put on malware that spies on other people. Keyloggers, when you download it onto someone else and they try to type something, you could see what they are typing. Okay, spyware and keyloggers are not the same. Spyware could see the whole UI, like see the whole GUI, the whole interface, whereas keyloggers can only see what the person type in. Remote access Trojan is usually used for installing backdoors. Uh, Rootkits. Rootkits are used for um, privilege escalation in a whole system, such as Windows or Linux. They could gain administrator privilege through that, and it's usually used by downloading fileless virus. A backdoor. A backdoor is basically when you try to hack into a system, and if you install a backdoor, it's kind of like a door that bypasses all security protocols. So if you use a backdoor, it will not alert the security. Password attacks. Number one, spraying. Spraying is basically using a set of passwords and inputting those set of passwords, like two or three passwords only, two or three passwords, that's like generic passwords, into a single login. If the single login does not work, they move on to another login. So for example, they may like use three passwords onto John, and then they'll move on because it didn't work to Zoe until they reach up into like a username that works with that password. Dictionarying is using public dictionary words that a lot of people like use for their passwords and just using that to get the password. So it uses plain text. Brute force, it uses a lot of different combinations. It may use hash to try and break and get the password. So there's offline and there's online. Most of the times, brute forcing is used offline because when you use online, your system will get locked out. Because you know those times when you try to log in, you get a lot of lock. You get if you try to like sign in a lot of times, you might get locked out. Yeah, that's exactly what it's trying to prevent. Rainbow table. Rainbow table actually take pre-computated hashes, so hashes that is already made, and it uses something like taking advantage of something called collision attacks, which I will explain something later on. But all you have to know is that rainbows tables are useless if there is a salt. I'll explain that one later on too. Plain text and unencrypted. So password, when you try to access it through an HTTP, and you use a packet sniffer, you could actually look at what people enter, and it a lot of times you can see the plain text of the password if you do not use hashes, or if you do not key stretch, which means that you try to encrypt that plain text, so it's unencrypted. Physical attacks, malicious universal USB cable. It is basically it can be a charger, like a charger cable, like an iPhone charger cable, but it actually has like a complete different system. It might have its own keyboard that is remotely controlled. The same applies with a malicious flash drive. So through that, you could also get like malicious scripts installed into your computer, or malicious spyware, keyloggers, all sorts of malware. Card cloning. I don't have to explain that. Skimming. You just try and steal that magnetic strip when in ATM machines. Artificial intelligence. So how do you taint artificial intelligence? The one easiest way is through tainting the training data. The most popular one is Microsoft Taint. Have you ever heard of that? Okay, it's okay if you do not know what that is, but AI basically uses training data for machine learning. It makes sense, right? Yes. So in Microsoft, Tay was released onto Twitter, and the machine data was Tay is essentially a chatterbot, but the data was tainted because a lot of people were being racist. So what ended up doing is that Tay started learning all the racist words, all the racist language, and Tay ended up being like an racist, anti-Semitic kind of bitch. That's why the most important thing is to do security on machine learning algorithms. So try and separate machine learning algorithms away from people, or like keep the training data away from the public. Supply chain attacks. Supply chain attacks basically mean it could be like the most random thing. So it can be an air conditioner company, right? If you hack an air conditioner company, uh, you could somehow hack the target's credit cards. It may sound really impossible, but it did actually, in fact, happen. So they hacked the air conditioner first, and then afterwards they pivoted into hacking the. I don't know how they managed to get through the systems, and they just ended up getting into the credit card processing. So it just stole like I think 1 million credit card information or something. Cloud-based and on-premise attacks. You really don't necessarily need to know about this one, so it's okay to ignore that. So cryptographic attacks. Number one is birthday attack. Birthday attack and collision attack is essentially the same. So collision attack is trying to take any hashes. Keep in mind I have to now explain hashes. So hashes is basically one way tickets. So when you put it into like, imagine you have a let me try and get this. So imagine you have this kind of number over here, and then over here is a whole machine. When you put this into the machine, it will come out as a hash. I suck at drawing, but it will come out as a hash. You cannot reverse the procedure. So, there's something called using probability by taking some kind of. So, imagine if you put a triangle inside, and it will come out as that hash. Uh, there's also a probability that if you use a circle, all the probabilities of that being a doppelganger will produce the same hash, and that is called a collision attack. So you don't really need to know the plain text of the password, but you could just try and keep making like I don't know random shapes until the hash result will become the same as the triangle. Uh, a downgrade attack. Downgrade attack is when you try to downgrade a system and you Google the vulnerabilities of that downgraded system and you just hack into it. It's mainly used for hacking SSLs. 1.3. Given a scenario, analyze potential indicators associated with application attacks. Privilege escalation is when you try to escalate privilege, like administrator privilege. Cross-site scripting. Cross-site scripting is using JavaScript, so using in any user input, and you put the script. When you put this script in, if there is a pop-up, wait, let me show this real quick. When you put this script in any user valid input and it has this come out, this means that it is susceptible to XSS cross-site scripting. Basically means I could, instead of putting the alert, I could replace it with like a malicious code and I could inject that code onto the server. There are also more different types of injections. There's the SQL injection. SQL injection is basically used for querying databases. DLL is used for Active Directory injection. Lightweight LDAP is by using just directories mainly. This is Windows directory. This is directories in general, by the way. XML. I'll get back onto that one next time. Pointer of difference is basically pointing application memory into a different place of application memory. It's hard to explain it. So imagine an application. So each application is destined for a certain memory place. So imagine this is Spotify, right? And imagine this is Facebook. Okay, when you run a Facebook application, the memory will run in this certain space in the memory. Redirection basically means pointing that place to another memory place while this one is using this one, right? When that happens, that causes the whole system to crash. Directory traversal is by basically trying to get through someone's directory using the web page. It's usually I have to explain HTTP. Google that yourself. Just Google directory traversal. I'm too lazy to explain that. Buffer overflow is basically this is also a memory attack. So if when an application uses this memory, right, and it has a maximum amount that's contained in this box, if you continue putting more memory into it, it will start causing an overflow to like the other sides of the memory, right? When that happens, that will also cause the system to crash. It will slow down processes and just cause the blue screen of death. Race conditions is when you try to mess up the order of the commands. So you know how code runs commands like one time at a time, right? So imagine if this function over here is put onto the function on top over here. It'll mess up the order, right? Yeah, you don't want that. That's gonna cause the whole system to crash. Error handling is when you do not handle the errors properly. The errors might give off information that is really confidential, and malicious hackers are gonna use that information to try and hack into your machine. So you're gonna have to like handle the errors by putting like general errors. Improper input handling is basically you don't sensitize, you don't like sanitize or like validate the input handling, which will cause a lot of these injections. So any of these could be used to put in like a search bar of some kind. Replay attack. Replay attack is by basically trying to steal a steal. Okay, it's stealing a cookie session and just using it for yourself. So a cookie session is usually like a bunch of like these random words, right? If you copy that in like inspect elements or something, and you email it to yourself, you could actually steal that person's session, and you will have that access to that person's account. So you don't even have to log in. You just replace that cookie with this. Yep, it's mainly if session replays is usually used like for later after that person log out, but a lot of times it has been protected because every time now when you try to have like a new session, the token, the session ID will get replaced every time to like a different number, so you can't actually have access to session replays anymore. Integer overflow. This is more also on the memory side. Is for example, if the application says that they will only use 10 memory, right? And integer overflow is basically editing that and just trying to make it into 100 memory. So that would cause like the integer whole thing to overflow. So it's kind of like a buffer overflow, but this changing the integers, which is inside the code itself. Uh, request forgeries. Request forgeries is basically using cross-site scripting in the input validation for in the input, but instead, it is used for stealing someone's sessions. So, you could like inject the cross-site scripting inside a link, right? And you send that link to someone else. Someone else gets it. They open that link while they're in session of like a Gmail account or a banking account. The malicious actor takes in that session, and it's now their session, and they're gonna use it to transfer money or some kind of stuff. That's all you need to know. So they inject it on the server side and use cross-site scripting. Well, technically they inject it through the client, right? And then they pretend that they're the client themselves, and they use the server side for validation to try and prove it's them. If I remember correctly, that's what it is. API attacks is exactly what I said. All of these, you gotta really like handle API attacks. It's very important for you to use error handling and improper input validation. Resource exhaustion is, as I mentioned before, the DDoS. So if you keep attacking like a machine, it's gonna cause like a machine to overheat because it keeps processing, right? It's gonna exhaust that resource. That's exactly what it means. Memory leak. Memory leak is another memory attack. When an application uses a memory over here, After you're done using it, a lot of times it goes back into the free space, so like other applications can try and use that memory spot, right? What happens is memory leak is you when after you finish using that information. This is a bad arrow. But anyways, after you finish using that information, right? The information does not get back out. The memory does not get back out, so it'll stay there. So it'll keep staying there as you keep using every time. So every time you use another one, you use like another space of the memory. Okay, another space of an empty memory. You're done. It stays in there, and then at the same time, you're running a lot of different applications. That's gonna cause like resource exhaustion, right? Because the memory is gonna be full and it's gonna shut down that whole memory. Secure sockets layer stripping is when you try to take down. It's usually a man in the middle attack where SSL is essentially a tunnel for you to like log into like HTTP or a web server, right? But what if you're in the middle? You spoof yourself as the server by, I don't know, using Mac spoofing or some kind. And this is the server over here. This is the computer itself, right? So the computer goes over here and you pretend to be the server itself, and you're inside the tunnel, so you have full access to the packet captures, so you can see inside what's happening. You pretend to be a server, okay? Driver manipulation. So you manipulate drivers. Shimming is by making that driver run on older legacy systems. It's trying to put like a bridge between like older operating systems and newer operating systems. This could be used for downgrade attacks. Refactoring is editing the source code, editing and modifying the source code for other reasons. That's pretty much all it means. Pass the hash is essentially a session replay where they try and take the hash and use it for later. Okay, 1.4. Given a scenario, analyze potential indicators associated with network attacks. Evil Twin is like a rogue access point. Rogue access point is just, those Wi-Fi's that randomly appears, and you could turn on your hotspot and that'll become a rogue access point. An Evil Twin is a rogue access point used for malicious purposes that tries to mimic like a current network that's available. Like for example, if I take my current network so an Evil Twin could pop up that's also called so it'll confuse people to connect onto that one instead of the so that I currently have. Blue snarfing is a Bluetooth attack where they try to use Bluetooth as a way to get your information, such as stealing your email information or trying to steal your calendar information. Bluejacking is basically using Bluetooth to send a message and scare people. So you could send a message of like, I trolled you or some kind of thing. Disassociation is called deauthentication also. So when you turn on a deauthenticator, it will disconnect you from the Wi-Fi, and it may also cause you to connect to like a rogue access point or an evil twin that mimics and that they could use it to like hack you. Jamming is Wi-Fi jamming, so blocking all frequencies so you cannot connect to the Wi-Fi. RFID is used for RFID is used for smart cards. So you could steal like the smart card interaction and try and log in yourself. NFC is used for card payments using your phone. Initialization vector is essentially salting. Let me explain salting really quick right now. So there's something called a rainbow attack, as I explained before. Rainbow attacks is basically a list of pre-computed hashes. So there are hashes that is put inside, the machine, as I said before, and these are just like all made already. These are not plain text. These are the hashes that is already made, and they use collision technique, right? So, usually, what people do is that they use like a login, right? And they put those hashes. Wait, let me draw a login. Okay, this is username, and this is login. They use those passwords and they put it inside here, and they try to like see which hash matches with the server. And if it matches the server, you get in. But what beats this is by using something called assault, also called the initialization vector. So it is basically putting an additional word to the password. So additional words that to the password. So you cannot like and then to hash this whole thing, right? Just so you know, they use like a really random generator. I don't know what kind of generator, but like just it just shows like a really weird add-on into it, so it just prevents like this because it will just result into like a separate hash. Da, 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 da. On path attack, also called man in the middle attack. I explained that. Man in the middle attack is was the SSL, the SSL thing that I explained. Layer 2 attacks. Layer 2 attacks is, as you learned before, the OSI layer model. So it mainly deals with the MAC address, MAC spoofing. So, MAC cloning. MAC cloning is pretending yourself to be. So hardwares are rooted with something called MAC address. So no matter how what you do, as long as I find your MAC address, I could try and actually chase the computer down. A lot of times, you could actually pretend yourself to be like another MAC address, which you could just clone a MAC and pretend that you're like your Mac one, your Mac two, instead that you're actually Mac one. Art poisoning is wait. Let me just do an example really quick on this part. So, uh, art is basically correlating the internet IP addresses to the physical address. So it's basically like DNS where they match the name to the IP address, but instead of the name, it uses MAC address to the IP address. You could spoof one of these IPs. So if this is a server, right? You could spoof this MAC address by like putting your own MAC address onto here. So you will now act as the server, right? That's what art poisoning is. Mag flooding, if you ever heard of using hubs, hubs sends information to all directions, whereas switches do not because they have their own mechanics and try and figure out where information is getting sent. But when you send a lot of MAC sources and addresses into the switch, it will cause it to have like a fail open safe mode, which will turn it into a hub. DNS. There's DNS domain hijacking is basically when someone steals your email and steals your Squarespace account. So they can now hack your domain by like, I don't know, doing anything to your domain. They could even delete your whole domain. That's domain hijacking. DNS poisoning is, as I said before, is how you see how here it matches to the MAC address. So for DNS, you can change the name. So imagine this is www.google.com, right? You could change the IP address to like redirect you to somewhere else. So when you do google.com, it does not redirect you to 8.8.8, which is the IP address of Google. You could get redirected to like 1.9. Blah 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 to like another malicious actor's website. And that's how you get hacked. You just poison the DNS. URL redirection is essentially the same as DNS poisoning. It is the result of that. You get redirected into another URL. Domain reputation. When a company gets hacked, or like if the company does half of the hacking and they don't know about it, Google actually has this thing where they flag like this email, or they flag like this this whole company in general as a really bad reputation, and they will not put it on Google. And what will happen when that company starts sending email to other companies or like to their customers, the domain email will get sent to the spam because Google does not trust them anymore because they are victims of breaches. So they think the domain is the hacker because someone hacked that system beforehand and the domain does not realize about it. Distributed denial of service. You could basically send a lot of bots to like deny the service of networks. You could do the same thing to application, and you could do the same thing to operational technology, such as you could use it for SCADA, you could use it for manufacturer computers, malicious script and execution. So these are all the languages that it's used for inputting malicious code or script executions. Number one is PowerShell. It is native to Windows systems. Python. Python is a very famous language that I'm also learning right now. It's a programming language. Bash. Bash is a low level language that is used by Linux. Macros. Macros is small functional codes that could like it's basically trying to automate. Macros is used for automating updates. So you could fake yourself as a macro and cause like a malicious update onto like a system. VBA, I think it's mostly used for Microsoft Offices, but it essentially does the same thing as macros. And there concludes it. 1.4, 1.1 to 1.4. Thank you.